Hello everyone, so we are from Group 7 here to present our final project for industrial statistics with the title Effects of Surface Type and Speed of Wind towards the amount of time that a ping pong ball could undergo in a fixed distance. Here are contents for the presentation. So for the background, DOE or design of experiment is a technique used to plan, conduct, analyze, and interpret data from experiments. It is often used when there are multiple factors that may influence the outcome of an experiment, and DOE allows researchers to determine which factors have an impact on the result and to identify the best combinations of these factors. In this specific example, the experiment using a ping pong ball is being conducted to determine the best combination of surface type and wind speed for the ball to travel the fastest. So the ping pong ball is a light hollow ball used in table used in table tennis, weighing 2.7 grams and having a diameter of 40 millimeters. And here are formulation of the problem. So our null hypothesis is that there are no effects of surface type and speed of wind towards the amount of time that a ping pong ball could undergo in a fixed distance. And our first hypothesis, there are effects of surface type and speed of wind towards the amount of time that a ping pong ball could undergo in a fixed distance. And the purpose of this experiment is by conducting controlled experiments under different conditions. We aim to determine whether the supertype and wind speed have a significant impact on the time it takes for the ping pong ball to travel a fixed distance. This information could be useful for ping pong players and coaches who are trying to understand the conditions that affect the trajectory and movement of the ball. Additionally, this information could also have broader applications in the field of sports science, and where understanding these factors that influence the movement of the ball, like weight of objects, can be useful for optimizing performances. Through this practicum, we hope to gain a deeper understanding of the factors that influence the movement of ping pong balls and to contribute to the existing knowledge in the field.
2K factorial designs involve K factors, each with two levels, often denoted as the high level and the low level of the factor. With K factors, there are 2K unique treatment combinations to which units can be assigned, and often the same number of units are assigned to each combination. Factorial designs are often discussed in an industrial setting where units are essentially identical and the assignments of units to treatment is arbitrary. However, in recent years, factorial design have become more prevalent in fields where pre-treatment covariates are available and units typically differ, including clinical trials, education, health sciences, and psychology. In our research, the response variable is the amount of time needed for the ball to reach a distance of 2 meters. The controlled variables are type and mass of ping pong ball, length of track, and operator. The nuisance factor are air friction, existing wind, and human error. The factors are surface type and wind speed, and lastly, the levels are different surface types, in this case, ceramic tiles and concrete, and different wind speeds, that is low and high. To test the hypothesis that surface type and wind speed does have an effect on the amount of time a ping pong could undergo in a fixed distance, we conducted a randomized controlled trial with a ping pong ball and a track made of ropes with the length of 2 meters. As wind speed is a controlled variable, we used a fan that has two wind levels and made sure that it was stable before letting go of the ball. In this experiment, we turned on the fan until the ball reached the end of the track. To measure the time, we used a digital stopwatch and made sure that the operator in charge of the fan and timing were the same for each replication. The data processing is carried out using a statistical model, which is the 2K factorial design model. It is demonstrated in Chapter 4. The conclusion of our experiments are drawn based on the interpretation of the results. Conclusions are drawn up to the answer to the objective of the practicum carried out. The practical conclusion can be seen in Chapter 5.
Moving on, we're going to talk about the result and analysis. And here we conduct the experiment in engineering center. The first one's indoors with the ceramic tiles, and the second one is we done it outdoors in the concrete. Here we make sure that there are no winds when we conduct our experiment, and then the fixed distance that we decided is 2 meters. with the lane that we made from our rope. And then the lane width is 5 centimeters. And now we have the data we collected. The one in the left is the data, and the one on the right is the data in the Minitab with the run order that is already randomized. The data we collected are in seconds. Moving on, we have the normality and the normal residual plot. And here, it can be seen from the result obtained that the residuals are normally distributed, as shown in the plot, and then the independence in the plot residual in time sequence. There's no visible correlation in the plot, indicating that their residuals are not related to one another. From this, we can conclude that the data is independent. Now we're going to talk about the homogeneity in the plot residual versus fitted values. From the residual and the fitted value plot pattern, we can see that the variance has been equal, as shown here. The tests for equal variance are done to see if the variance of different treatment groups are equal or not. The p-value obtained are 0.30504 and 0.446, which means that they are greater than the alpha that we chose, which is 0.05. We can say that we have an equal variance in this data. And here we have on the left that each of the factors overlay each other, which means they're equally distributed. And here we have the versus fits in residual versus fitted values, and we see that in the pattern here that we can say that the variance are equal. Now we're going to talk about the research data and results. The p-value obtained in this observation are all less than 0.05, which is the alpha that we chose, which means that they are all significant factors. And here we have 0, 0.008, 0.008 also. And then down here we have the model summary where we have the R-squared. R-squared is loosely interpreted as the proportion of the variability in the data explained by the ANOVA table, which is above here. We can say that the R-squared is model fitness with R-squared 95.85. The data we collected is acceptable due to these two factors, 95.85% variation that are occurring in the time or speed of wind, the first factor, and surface.
Okay, so now still on this analysis, as we can see here, the F values are relatively high that if we compare with the F critical values on the F distribution table, we most likely will obtain a conclusion that the F values are greater than the F critical values. So, as an example, let's take the F value of surface type here, which is equal to 37.35. If you see the F distribution table with alpha equals to 0.05, V1 equal to 1, and V2 equal to 12, we will obtain that the F critical value will be 4.75, and this value is smaller than the F statistic that we obtain. Therefore, we can reject the null hypothesis and conclude that there is significant difference between the amount of time that a ping pong ball could undergo on the ceramic floor and concrete surface. The same method applies for other factors until we reach the conclusion that there is effect of wind speed and surface type towards the amount of time that a ping pong ball could undergo in a fixed distance. Okay, so now we move on to the coded coefficient. As you can see here, there is effect column and coefficient column with various values. The relationship between this effect and coefficient is important to make further predictions. So the general formula will be y equals to a, which is the constraint, plus b1 as the coefficient of wind speed, times x1, which is indicating the first factor, plus b2 x2, that is indicating the second factor, which is surface, plus b3 x3, that is indicating the interaction of time times pressure. So substituting the values, we will obtain the regression equation is t equals to 3.8951 minus 1.0237 times wind speed plus 0.4125 times surface minus 0.2138 times wind speed times surface. Note that under the coefficient column, it is basically the multiple regression line. In the end, we have VIV here, which stands for variance inflation factor. This is basically used when we have multiple factors that we need to check whether there is multicollinearity or not. So the idea is if the variance inflation factor is 1 or near to 1, that means no particularity exists in a model. Particularity here means there's no relationship between time and pressure, so they are considered independent as variables.
Now I'll be explaining about the main effects plot. As we know, factor effect is a change in the mean response when the factor is changed from low to high. Based on our findings, the figure shows that changing the wind speed from low to high has a significant effect on the mean. Now to the interaction plot. In this plot, it is shown that two-way interaction is significant with a p-value equals to 0.008 is less than the alpha. This can also be proven with the Pareto chart of the effects. Here we have the Pareto chart. In these results, the two main effects are statistically significant with the alpha equal to 0.05. These significant effects include all two main effects, which are wind speed and surface. In addition, you can see that the largest effect is the wind speed because it extends the farthest, and the effect for wind speed by surface interaction, which is AB, it has the smallest because it extends the least.
Next, we have the conclusion of this presentation. So, the experiments and analysis that we have done confirms that the F value is greater than the F critical. Hence, we reject the null hypothesis and conclude that there are significant effects of surface type and speed of wind towards the amount of time that a ping-pong ball could undergo in a fixed distance. And the best combo that we have is to reach a fixed distance. The fastest is on ceramic floor with high-speed wind. And next, here are the references that we use for this experiment. And finally, we have reached the end of this presentation. So, us Group 7 would like to thank you for listening and having a watch for this video, and we apologize for any mistakes. Thank you, everyone.